Hi friends, very good evening. Welcome back to the session. Thanks for your time in attending the session. So the domain trade analytics we are looking into from past 7 hours, that is 7 days. So let me list what we have discussed in a day one and day two and day three and day four and day five, day six and day seven. And today is the final day. So first day, we have seen the application of machine learning and AI. And second day, very important project management methodology. We have seen the difference between CRISP DM and CRISP MLQ, the project management methodology. And day three, we deal with the data, how to explore the data and analyze the data with the different steps and understanding the data. If something is missing in the data, how to fill the gap and how to understand the data is all about EDA. So this EDA step is very much needed for all the algorithms. Before creating your model, before designing your model, you need to train your data. So data will be a raw data, where you'll be having a raw data with structured data and unstructured data, and you also have semi-structured data. So these data you need to arrange it as per your analysis and problem statement, and within your constraints you need to be ready with the data. So then you design your model. So here we selected different models in different days. So first we have seen the clustering algorithm, that is K-means algorithm. And then we looked into classification algorithm, that is KNN. And then we looked into regression algorithm, that is linear regression algorithm. And then we started discussion with regards to decision tree, so which is again classification. So today, this is all about with respect to the machine learning models. So machine learning models deal with the trade analytics or trade data or stock analysis. But today we are going to understand, the first day I've told you that neural network also contributes and work on the regression problematic problem statement and also classification problem. So here, today we try to understand how this neural network is designed and how it is, what all things that does it have, and how it is helping trade analytics, and also whether it is with respect to classification or regression. So when do you say whether the given problem is with respect to classification or regression? So when you have the data continuous, then it is referred to be as regression. So when you have a categorical data, so that is discrete data, so we'll be having classification problem. So here in the trade analytics, you are analyzing the trade with the volume and with the price or the close price that you have. So let me rewrite. So when I talk about the stock, you will be having open price, close price, high value and low value, and the volume that has been sold and the relative price. So these are the important parameters with respect to the stock or the shares or the trade. Okay. So now we pass all these values and we analyze a particular company's trade history, and then we'll decide whether to buy or sell the shares. So we predict the value based on the output that we are getting, and the past history of the data, history of the company is required. So with the help of past history, we analyze and we make our model to get trained on the all the possibilities, and we just analyze it to get whether it is to buy or sell. Okay, so now we just try to understand the data and then deal with the problem. So first we need to understand what is neural network. So neural network consists of input layer, output layer. In between, you will be having hidden layer. So input can be of text data, can be of image data, can be of numerical data, can be of audio signals, can be of video. So we call all these format as unstructured format. Unstructured format. So why we are learning deep learning when we already have machine learning traditional model? So deep learning is a concept where it is going to learn by changing the weights, and it is going to get retrained upon several iterations. Let me give you a simple example. So first day we analyzed some data. This is a data. So first day we analyzed the data and we understood that the shares are going high with the company. The second day also we analyzed and we understood that the data is the shares of the company is going high. So what is the third day? So when it is increasing 0.5%, 0.5%, you may also predict that the third day, based on different features, it may cross or it may increase 0 to 5%. So this is your prediction based on the past history. But you got trained based on these past history and you predicted. Say same thing, the particular network is also getting trained and it is going to learn from that. So let me take a whiteboard so that I can explain you what does neural network consist of. So you'll be having an input nodes, okay, and you'll be having the neurons at the hidden layer, and you'll be having output. So this output is from the input given. So everything should be connected. So this is the neural network. So here you will be giving you the input, and this is a hidden layer, and this is a output layer. So we are predicting here y cap. We are predicting here whether to buy or sell. So you'll be getting output with the probability. So the probability of saying 96% of buying and 4% of selling, or it can say 86% and 14%. So it can say 66%, 34%. It can say 56%, 44%. But even though it is saying 56% and 44%, this is the higher rate. We'll go with buy. So we use multi-layered perceptron. We call it as MLP. So we also call this as deep learning, that is artificial neural network concept. So we also call neural network. So there are different names. You can call that as a ANN, deep learning neural network. So deep learning also can be have ANN, CNN, and RNN. So this is with respect to some numerical data. So this is numerical data, and you will be having a text data. I'm so sorry. So you'll be having image data, and this you will be having text data. So where you will be having NLP concept, that is natural language processing. RNN means recurrent neural network. CNN means convolution neural network. ANN means artificial neural network. So different data, different networks. Okay, all this under deep learning. So the name itself says that you learn deeply. So deep learning, as much as you can learn deeply, and you can just get updated. So if somebody is learning for more than 8 hours, if he's studying for 8 hours daily, he'll be scoring at least 90 to 100 percentage. He can score 90 to 100. He can aim because he is studying for 8 hours daily. In the exam, he can score because he's learning. So when I say there is a person who is studying daily 1 hour, he is also scoring 90 to 100%. So do you think that we can degrade this person who is studying for 1 hour and this person is studying for 8 hours? So we can't degrade the person who is studying for 1 hour and getting scoring 90 to 100%. So this is his person capability of understanding, and this is the second person capability in understanding and getting the percentage. But you just need to understand at what way they are understanding and learning. The second person needs more training. Only then he can score 90 to 100%. So the first person needs one-time training. He'll quickly learn and he'll score 90 to 100%. So this is not the case in neural network, but when you have a neural network, you'll be having the connections and you'll be learning with the weights. So these are referred to be as weights. And these are referred to be as neurons. And these are output neuron. This is hidden layer neuron. And these are input layer neuron. So in neural network, we have a hyperparameters. So we have hyperparameter. Let's say example, we have a data. We have a data and we have observations and we have features. So all these are features, the first column. And from the second, you'll be having 100 data. So let's say example, we have 100. So we need to pass the complete data, all these, this also, this also, this also, this also. At the end, you will be having the value, that is output. So this will be considered to be as output. So this output will be given as an actual output. So when you pass these parameters, are you getting this output? We are cross-verifying. So we are predicting by passing this value into the network. Anyone, even a human being, if they are studying for first time, what is the amount of accuracy level of understanding the concept? What level they'll understand for the first time? This is the question. Even if it is a human being, they have a capacity of understanding 40%. So they're not accurate, they're not maximum, they have some more errors. That is 60% of errors. This is accuracy of first instance. Now, the same concept I will explain for the second time. Now what happens? The error will get reduced, saying that 40%, and the understanding level increases. It becomes 60-40. Next again, third time. What is the accuracy? Third time. Again, at least 10% it increases and it decreases with the error. Fourth time, fifth time, and increases. So that is what we are doing. So the whole data is passed through the network and getting what are the values. So whenever you get a value at the end, when these observations are passed through the network, you will get some value. So here we are getting this value. So this value is referred to be as predictions or prediction value. So when you are finding error, you are supposed to calculate the difference between the prediction value and the actual value. So I'm getting here saying yes. So here the actual value is no. Let us assume that we have an output of saying yes or no at the end. Buying the trade, yes, or not buying the trade. That was the output. So the first instance says it is no. But at the first time, when these observations are passed, values are passed, it is giving me yes. So that means you have an error. The required actual should be no, but it is giving me yes. So what I'll do is I'll just go back and then try to make understand that no, you're supposed to get update and you will be saying no. So I've told the human being for the second time with the same concept. I'm not repeating the same way of understanding, making an understanding. Same concept, but not in the same way. So I'll change my explanation and give more example. so that for the second time, he may understand, he will understand, and he will improve the accuracy. So for that, what I'll do is I'll just make this go back and then again get trained. Now what happens is while going back, all these weights will get updated. So we call that as gradient. So whenever we have an error, so we go back and then update. So in neural network, this is going back when you have an error is referred to be as back propagation algorithm. So artificial neural network is also referred to be as back propagation algorithm. So why we are updating this weights? Why we are concentrating on weights? When I write a particular neural network, I'll be getting an output where in the neuron, where you'll be having two things. One is sigma and one is activation function. Sigma is collecting all the inputs and their respective weights, W1, W2, W3, W4. Okay. So you have X1 into W1 plus X2 into W3, W2, X3, W3, X4, W4, and X5, W5. Like this, you will be having summation and it will calculate. After calculating this, we'll have a activation function of the same. So let it be Z, Xi, Wi, Z, and I'll apply activation function on Z. Now, why is this activation required? Why is this sigma we are doing? Let's say example, a man is sitting, a man, I got a hotter glass, hottest, the glass of water, which is hot. And I'll make that particular glass to touch with the hand of human being. That is a man. So I'll make a left hand, I'll make a hot glass to touch his left hand. Now, what the man will do, what he tries to do, he will try to, he will try to pull his hand away from the glass. So he is trying to pull the hand away from the glass. Don't you think that they have at least 1 second reaction time or 2 seconds, milliseconds, some milliseconds? Immediately, even if it is immediate, they have some response time because that particular intensity of the hotness, we need to send it to a brain. The man need to send that information. There is some hotter glass touching my left hand. With the help of nerves, it will travel and go to the brain, and it will inform brain to man saying that you lift your hand. So this is the process that will happen when there is a action. So same thing, when a particular node has been activated with weights and inputs, there should be someone to say that it is activated and giving as an output, or this is a brain. So it is giving you and telling you again what to do. So the input is I Let's say example, you are seeing something from the eye, or you are feeling something from the skin, or you are hearing something from the sound, you are talking something. So everything will be your input and everything will be connected to your brain. So when the hot glass has been touched to the portion of left hand, the man tries to pull the whole hand. So on the portion of the hand, the glass has been touched with some intensity. If it is very small hot, if it is not too much as per room temperature, if it is not 100 degree or 90 degree Celsius temperature water, he will immediately remove the hand. If it is mild hot, it is not so hot, and he will not remove. So that intensity level will reach the brain. Let's say example, it is too hot. He will immediately remove. If it is mild hot, so he'll try to remove, but not immediately, after some time. And if it is less, very less hot, he might remove the hand or he may not. So probably he'll just turn back and say what you are doing. He'll not remove the hands. Now the variations in this. Okay, if he is removing the hand for the first instance, then this will be the too much hot for the person. So this too hot, mild hot, very less hot is considered to be as weights. My intention is man does not want to remove the hand. But when it is too hot, he tries to remove. Quickly, he tries to remove the hand. If it is too hot. What is my actual output is does not want to remove. Now for that, what I should do? I should cool for some time, make it as mild or very less, and then need to again make him touch, and then now I'll give it as he is not removing the hand. So while going back, I am changing this. Again, I am doing the same process. He is not removing the hand. Simple. So while going back, you need to change the weights which has been randomly assigned with the value between 0 and 1. So you need to update. For the first instance, few values are randomly taken and then it has been assigned. Now while going back, you say that I got this output, your value should be changed. I got this output, this value will be changed. So the value will be dependent on the output at the neuron. This is 1 and this is 1. Okay, so this output is dependent on these values, and these values are dependent on the output of this neuron. So where you will be having sigma as well as activation function. Here also sigma and activation function. So this output, so these values, and this value is output is dependent on all these weights. Because we are doing sigma xi wi, this is a ultimate function that we are doing. So while going back, you'll say that I got different answer, please change this. I'll say, okay, I'm depending on this fellow, so he needs to change. So he'll say, I'm dependent on this fellow and also weight, I need to change this. So ultimately the weight is getting changed, and again it will start traversing from the input node to the output node, and it will get changed. So now we are getting actual value. So actual as well as prediction value will be same. So then we'll say that it is predicting properly, and we'll stop there. So this is what a neural network which is doing, and it is deep learning. So with this concept, we'll try to understand whether it is going to buy or sell with these two categories, and try to understand how this network, the neural network, with the data, it is going to react. So we'll see that now with the practical session. So hope you are able to see the screen. Okay. So we have a Google stock price. Okay. So we have taken Google company and their stocks, and we have divided into the train as well as test. So why we are doing this? Because I'm creating a model and I need to make this model get trained. Only then it will be ready for next in future data. So I'm not picking any in future data. Whatever data that I have, I'll just split that into train and test, where 80% of the data will be trained and 20% will be remaining for testing. It is something like a complete. Okay. This is something like there will be a chapter 1, chapter 2, and under this, and chapter 3. Okay. So like this, you will be having a syllabus to study. Now we have 3 chapters and you will be having first test. What the teacher is going to train the model, train the students with chapter 1, chapter 2, chapter 3, everything. So she'll train everything. She'll guide, she'll give the notes, she'll tell which are the important questions, everything. After learning, the students need to take a test. Does this test will come from contains a question from chapter 4? When I say there is a question in test 1 referring chapter 4, then it is out of syllabus. Because you doesn't know how to answer, you doesn't know the answer. So you fail. So the test accuracy will go down. You already trained, your train accuracy will be very high. You're almost 99% you have studied, prepared chapter 1, chapter 2, chapter 3. You are ready, but you got chapter 4 question. Your accuracy will be go down, the test accuracy. So then you say that it is having overfitting. So overfitting is a concept when you have train accuracy higher and test accuracy is lesser. So what we'll do is we'll just do chapter 1, chapter 2, chapter 3, and in test we'll give chapter 2 question. And we'll test for the data, test for the student accuracy. So what I can say is the student is also getting trained on all the chapters and almost prepare for 99%, and he has been given test on the same chapter 2 and he is also scoring 95%. Of course, even when you are preparing 99%, we can't score it as 99%. So you will fail in getting 4%, but it is almost there. It is almost there. So this is something like a good fitting model. So you also have overfitting concept. When is that overfitting concept? When train accuracy is high and I'm so sorry, test accuracy is low. And now we also have underfitting concept. When the train accuracy is very low and the test accuracy is also very low. So something like you're not preparing, you're preparing only 40%. You have prepared for only for 40%, and the test accuracy is also giving 35%. So it is underfitting. You're not passing. So you're not up to the mark, not satisfactory, below average student. So that is all about underfitting. So you need to keep in mind this, and when you are training the data. So when you are considering the data, you first get the data and read that as a trained data. So you read the data. So date, open, high, low, close, one. So now I have considered the data. Now I am considering the training data.ilog with the complete rows, all the rows. But I want to get a training data with column. So what is this column 1:2? It means start with first column and end with second column, excluding the second column. That is the meaning. So when I say exclude this and start from this, now what is the meaning? It will consider the first column. It will consider the first column. So when I say I log first column means the log will start from 0, 1, 2, 3, 4, 5. So that means it considers this. So I'm getting trained with the model with open. So hope you are getting this and the shape and the value. So we need to concentrate on open value and then we are predicting. Now, so we have sklearn.preprocessing min-max scaler. So it is fitting the data and it is going to check whether the data is balanced or not or having any imbalance. So it will cross verify and it will get updated with the fit transform. And now I'm just selecting the values for train data. So X train and Y train. So I'm selecting some portion of the data as X train and some portion as Y train. So X means inputs and Y means outputs. And then we are proceeding with the data, which is having a shape of 1257 and one row, the column, one column. So I'll just show you here. You can see this one column and 1257 rows. So that is a meaning shape. Now we'll reshape that to 1257, 1, 1. Now we'll use some of the packages which is very much required for neural network. So which is Keras. For Machine learning library, we have pandas, numpy, matplotlib, matplotlib.pyplot, seaborn, sklearn. So like this, you have ML library. So when it comes to deep learning library, so you have Keras, PyTorch, TensorFlow. So like this, you have many other deep learning libraries. So what it will do, so it will create your network. I've drawn your network, right? It will create the models in sequential format. Dense is all the connections, and you are using LSTM RNN. So we are using LSTM RNN, neural network. So what is LSTM? Long short-term memory RNN. So what does the RNN do? It is going to have input at time t1, and you will be having hidden state at previous time, and you will be getting an output at time t1. So this hidden state is going to have temporary data, and the y is output. Again, this value will get stored for the next. So I'll just unfold this. So you'll be having like this. So this is ht minus 1. This is x1 at time t1. This is x2 at time t2. This is x3 at time 3. This is x4 at time t4. So you'll be getting y value t1 and t2 and t3 and t4. So this becomes ht1, this becomes ht2, this becomes ht3, and this becomes ht4. So this is a recurrent neural network architecture that has been created with the help of LSTM. So where LSTM will have memory cell, input gate, output gate, and forget gate. So it is using all these for recording. So here we are seeing that memory cell is going to use a long term where it is going to hold the data, and input gate, forget gate, output gate are temporary gates. So it is taking input and getting updated for the next input. So it is getting output and it will get updated whenever you have a new output. And forget gate, it is going to understand what amount of data or which data to be forget. So now the architecture has been created with sequential, dense, and LSTM. So TensorFlow is the backend. So because the Keras is under TensorFlow. So after greater than version 2.0, so TensorFlow and Keras are one and the same. Okay, so both are same and both are framework for neural network, which is helpful. So now we initialize the model sequential, like first hidden layer and next first input layer and next hidden layer and then last output layer. So like this, you'll be having a network in a sequential format. Next, you have LSTM with 4 units and activation function with sigmoid, and input shape is none, 1. and you'll be having a output layer with a dense unit of 1, either to buy or not. So compiling the model with the optimizer, what optimizer is doing, the optimizer is going to update the weights. When you are going back, that means you are learning, you are getting trained again. So Adam is the optimizer that we are using. So we have different optimizer like gradient descent, stochastic gradient descent, mini batch, stochastic gradient descent. I'm so sorry. Stochastic gradient descent with momentum is also there. Okay, so these are all optimizers, and we have ADA grad, and we have ADA delta, we have Adam, and we have this is also referred to be as RMS prop. So like this, you have different optimizers that is going to update the value. So now I'm using loss function as mean squared error. Why I'm using mean squared error? Because the values are continuous. So when the values are continuous, you'll be having some regression methods or regression values, regression techniques. Hence, it is linearity. So when you have linearity, you'll be making sense with mean squared error, root mean square error, mean absolute error, mean error. So like this, you have loss function, calculating the loss. Whereas when you have a categorical data or classification data, so you'll be having a binary cross entropy, and categorical cross entropy. Categorical cross entropy. So you have two things, multi-class and binary class. So we are using mean squared error because you have the continuous value, only one row that is open. Now we fit the model with batch size. So batch size is going to decide, let's say example, we have 1000 data. So we have pick 1000. So it is going to split as batch wise 32, 32, 32, 32 till it covers 1000. So this is going to have first time getting into the network. So next 32, it will randomly pick and then send it. And it will randomly pick and send it. It will randomly pick and send it. So it is going to pick randomly and then send it to the network. So that is batch wise. So why we are doing batch wise? So it is easy for that to learn. So it takes less time. Okay. So whenever you have a syllabus, you will not learn everything at first day. So first day you will learn chapter 1. Second day you will learn chapter 2. Third day you will learn chapter 3, so that you can easily remember based on the chapter wise. So we are making batch size. So now we are running the batch with number of epochs and making the loss value less. So you can see that initially it will be 0.9%, 0.09 as a loss. So as it decreases, it reduces and becomes almost equal to 0. So here you are getting a real stock of the value, and we are importing that to test. So Google stock price testing. So again, I am dividing that and getting only the open. So now for this model, if the loss is almost 0, that means 99% it has been trained. And for the given data, next test data, it needs to predict. So real stock price, transform the data inputs and reshape it as 20 one by one, and then predict the stock price, predict of inputs, and inverse the transform, predict stock price, and you'll be getting these values. So you need to predict by plotting it. So for trained data, it got understood with the activation function, optimizers, everything while training. But while testing, it is just comparing with the data that you have. Okay. So here I just calculate the comparison with the help of graph. So you can see that the red color is actual value and the blue color is predicted value. So it is almost same. It is increasing, decreasing, almost same. So you can see that almost the same means error is very less. That means indirectly I'm saying accuracy will be high. So again, you can just give a train CSV with a Google and then go with the prediction with respect to different column and then take the value, train the model, and you get the root mean square error. So I'm calculating root mean square error, that is only 4%. So 96% it is accurate. So first we got the train the model by using train data. Next you will pass the test data into the model and you will be knowing the accuracy. So if these two are same, then you will say that the accuracy is high. And how do you evaluate this? So evaluation with respect to matrix. That matrix is mean squared error. So we'll calculate the root mean square error. So that particular error function will tell you or evaluate and give it to you so that your model is accurate with less error. So this is what we learn and try to understand with the help of neural network. So this is good with respect to regression and with regression problem and also classification model. And this will be very accurate. So I was supposed to tell you why we are moving towards deep learning when we already have so many machine learning models. In machine learning models, we are getting error rate of more than 10%. So we are not receiving or reaching 90%. So if the error is 10%, the deep learning is 4%, you can see that it is accurate. So deep learning is bit accurate when compared to machine learning. So this is all about neural network. So if you have any doubts, you can just mention in the chat box so that I can answer and we can discuss. So if you don't have anything to discuss, it is good to wind up. We'll meet in the next domain analytics. We'll stop here and please do subscribe for the channel and go through the Python session that is undergoing and also all the domain analytics sessions and make use of it. So that it will be helpful for you. So please do subscribe for our channel and also follow the platforms, social media, that is Twitter, Instagram, and LinkedIn. We are very active and we are also posting a useful post where the students might get the data science question, artificial intelligence question in their respective interviews. So those particular exact interview questions will be posted in the platform. So you can just subscribe for our join the group so that it will be useful for you to get the questions. Make yourself arrange one side, make it as a document so that it will be helpful for you whenever you go for the interview. So like this, you make use of it. We are always here to help you and then understand the concept easily so that it will be helpful for your future. If you are interested in learning artificial intelligence or machine learning. Okay, friends, we don't have any questions here. So good to wind up. So probably I took 1 hour to explain at least some portion of neural network. So please try to dig into that and start exploring with this basic concept. And we'll see in the next domain. Thank you all. Have a nice time. Have a great weekend. Bye. Take care.